નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Hello students, let us continue our exercise 9.5. This is the exercise of standard 8 chapter number 9, algebraic expressions and identities. So we have studied the two questions in last class. Now let's study the question number 3. What is the question? Question is find the following squares by using the identities. So here we have to find out the squares. So first sub question we have given like this: b minus 7, b minus 7 all square, right? And we have to find out this square. So here we have to use the identity number 2, which is a plus b whole square, right? It is like this: a plus b whole square, sorry, a minus b whole square. The second identity is for the minus. So here we can write down it as a square minus 2ab plus b square. And how we can write down this thing, that you know now very well, right? Okay, so here we have to consider a as a b and b as a 7, right? So same thing we have to apply for this b minus 7 whole square, that is equals to square of the first term, that is the square of b, minus 2 into first term is equals to b, and second term is equals to 7, plus square of the second term, that is b square. So here we have to write down square of the 7. So the simplified form now is b square minus 7 2s are 14b plus 7 7s are 49, right? So this is the extended form of this b minus 7 all square, right? Or we can say that the square of this algebraic expression is this, right? Okay. Let us see now the sub question number 5. Sub question number 4. Right? Here there is a 2 upon 3 m plus 3 upon 2n whole square. Here we have to find out the square of this bracket. Here we have to use the identity number 1 because the positive sign is here. So only the change is that here we have to positive sign. So it will, this term will also become the positive. So let us apply. We have to make first of all the square of the first term, that is 2 upon 3m whole square, right? Now second term is 2. First of all we have to put down the 2. Now we have to multiply both the term. The first term is equals to 2 upon 3m and second term is equals to 3 upon 2m. Now what we have to do? Now we have to apply the square for this second term, that is 3 upon 2n bracket square. Right? It is actually very simple. You just have to remember to follow this identity. That's all. You do not need to see that there is a 2 upon 3 and there is a decimal number, so it is very difficult. No, it is not actually difficult. You are making it difficult. So don't make it difficult. Just follow this identity. Right? Now see what we can do here. We have to apply the square. 2 square is equals to 4. 3 square is equals to 9, and m square we can write down it as m square. Here what will happen? See, 3 and 3 they are in the denominator and the numerator. We can cut. 2 is also we can cut here. So what will remain here? 2m n. 2m n. That's all. Plus here what we can write down? 3 square is equals to 9. 2 square is equals to 4, and n we can write down as a n square. That's all. That is the answer. So these three terms we are getting when we apply the square of 3 by 2m plus 2 by 3n all square. Right? Okay. Let us see one of the question that is of decimal number. So here is the question number 5. That is 0.4p 0.4p minus 0.5 cube, 0.5 cube whole square, right? So here also we have to use the identity number second, that is this identity, right? Because negative sign is there. So we have to apply the square of the first term. So we can write down it as a 0.4 p bracket whole square. Now negative sign is there, so we have to put the negative sign. Put first of all 2, multiply the first term and second term, that is 0.4 p, and here there is 0.5 q. So here we multiply both the first term and second term, and also multiply it with the 2. Now the third term here we have to put down like the square of this second term, that is 0.5 q whole square, right? Okay, so now let us apply the square. What is the square of 0.4? We know the square of the 4. The square of the 4 is 60. 4 fours are 60. But there is a decimal point after one digit. So in 16 we have to put the decimal point after 2 digit. So it will become 0.16 p square. We can write down like this, p square simply. Here also we have to multiply these two numbers, 0.4 and 0.5. So 5 fours are 20. Here also both the numbers are in multiplication and both have one after one digit there is a decimal point. So in multiplication, whatever the answer we get the 20. We have to put the decimal point after 2 digit. So here we get the 0.5 fours are 20. So we can get the 0.2 and we have to multiply it with 2. So like this, see, we can write down 4 upon 10. 0.4 is 4 upon 10. 0.5 is 5 upon 10. Now what is that we are getting? 5 fours are 20. 20 upon 100. Now 20 upon 100, we can cut one of the 0 and now we can write down it as a 0.2. Now multiply it with the 2. We get the 0.4 p as it is and q as it is. So 0.4 q is our middle term. Now here 0.5 square. 5. We know the square of the 5 is 25, but 0.5 is 2 times. So again we get the denominator 100. So we have to put the 2 decimal point. We get 0.25 q square. Right? So what are the difficulty that you are facing is that how to multiply these decimal numbers. So it is actually very easy, right? So don't just make it difficult. Okay, you can solve any type of these questions. Okay, so now let us study the question number 4. Question number 4 is, here we have to simplify some of the given identities or some of the expressions. Out of that, first one here is that a square minus b square whole square, right? So there is a square on the bracket, so and the negative sign is there, so we have to use this identity, right? What we have to do is make the square of the first term. First term is a square, so we have to make the square of the first term. Do not confuse here, because we already here given that a square. Maybe you think that already there is a square, so no need to do the square, but that is wrong. Whatever we have given as a first term, we have to apply the square. Either it is a square or a raised to power 4 or a raised to power 50, whatever is that, we have to apply the square. Okay. Now middle term is negative 2 a square into second term, that is b square, and lastly we have to apply the square of the second term, that is b square square. Okay, now further simplification we can do here is that a raised to power 2 in 2 and 2, so 2 to the power 4 minus 2 a square b square plus here we get the b raised to power 4, right? So this is our simplification of this sub question number 1. Now let us see the sub question number 3. Sub question number 3 is like this: 7m minus 8n whole square plus 7m plus 8n whole square. See, two identities we have to use here, right? First, if we have to apply the second identity, that is this identity to here, and here we have to apply the first identity, that is of positive sign. So here when we apply the identity, we can write down it as a square of the first term, that is 7m square minus 2 into first term into second term, plus square of the second term, that is 8n square. Here we apply the identity for this term. Now we have to apply the identity for this term. So here we can write down 7m whole square plus 2 into 7m into 8n plus square of the 8n, that is 8n square. Okay, now let us simplify. Here we get 7 square is equals to 49 m square. Here we get the 7 to the 14, 14 8 the okay, 8 to the 16, 16 7 the. Here we get the 14 8 the, that is 112 mm. Here we get the 8 8 the 64 n square. Now the same thing here we have to do, apply the square of the 7, that is we get the 49 m square. Here again the middle term we get is equals to 7 to the 14, 14 8s are 112. The same digit we get here, 112 mn plus 8 square is equals to 64 n square. Right? So here we get this 6 terms, first, second, third, fourth, fifth and sixth. Right? So now see, you can see that this term and this term are the like terms. So one is positive, one is negative. So we can cut it like this. Okay. Further, if we can see that this 14n square and this 14n square are also the like terms, so we can add them. We get here 98 m square, and 64n square and 64n square are also the like terms. We can add them. What we are getting here is 128 n square. So this is our final answer. This is the simplification of the square of the first identity plus square of the second identity. There is a positive sign, so here we have to apply the positive sign. Okay. Now let us study the question number, sub question number 5th one, 6th one, that is AB plus BC whole square, AB plus BC whole square minus 2A B square C, minus 2A B square C. So here we have to simplify this. For the simplification, we have to first of all apply the square here. So when we apply the square here, what we are getting, AB is the first term. So we have to apply the square for the first term. Now the middle term is the 2 into AB into BC. And then we have to apply the square for the second term, that is square of BC. And this term we have to write down as it is, 2A B square C. Now when we apply the square, here we get the A square B square. What we are getting here is 2A is 1 time, B is 2 times. So we have to put here B square, and C is 1 time. Right? Here we get the B square C square. And last term we get here is 2A B square C. Now we know that the simplification is possible only for the like terms. So these two terms are the like terms. One is positive, one is negative, both are the same, they both cancel out. So what will remain here is A square B square plus B square C square. That is the simplified answer. Right? So in this way, now you can solve this type of the questions. Right? You just have to use the identity just to follow the identity. That's all. Okay? So this is all about this lecture. Thank you.
Thank you for joining us.